Hi everyone. Today we will study Introduction to Number Systems. In particular, we will discuss natural numbers, whole numbers, integers, and rational numbers. First group of numbers is called natural numbers. This is denoted by capital N. The most basic numbers used in algebra are those we use to count objects. So we have 1, 2, 3, 4, 5, and so on. These are called natural numbers. Natural numbers are also called counting numbers. Using the set notation, we write it like this. Capital N equals the set with elements 1, 2, 3, 4, 5, and so on. Note that a radical that can be simplified into a natural number is considered to be a natural number. Example, the square root of 25 can be simplified into 5. So this is a natural number. Next group is the whole numbers. This is denoted by capital W. The whole numbers are the natural numbers and 0. In set notation, we write like this. Capital W equals the set with elements starting from 0, 1, 2, 3, 4, 5, and so on. The next group of numbers is the integers. This is denoted by Z. The set of natural numbers, their negatives, and 0 is the set of integers. We write this in set notation as capital Z is equal to ... There are some numbers on the left side. So we start here with negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. Using the number line, we write in the middle the 0, and on the right side are 1, 2, 3, 4, and so on. These are the positive numbers. On the left side of 0, we have this negative 1, negative 2, negative 3, negative 4. And we call this the negative numbers. There are notes here. Number 1, a negative number is a number that is less than 0. We could write a plus sign. This is the symbol before a positive number, such as positive 2 or positive 3. But it is customary to omit the plus sign and write only the number. If there is no sign, the number is assumed to be positive. Next group is the rational numbers. We denote this as capital Q. A rational number is a number that can be written in the form P over Q, where P and Q are integers and Q is not equal to 0. In set notation, we write like this. Capital Q equals P over Q such that P and Q are integers and Q is not equal to 0. Numbers under rational numbers are integers. We have some examples: negative 2, negative 1, 0, 1, 2, 3. Fractions. Examples: 4 over 5, negative 7 over 8, 13 over 4, negative 20 over 3. The decimals, but these decimals must be either stops or repeats. Examples are here. First example, 0.8. This is a decimal that stops. So this is a rational number. Another example, 2.1757575 and so on. We can see here a pattern of repetition on the 75. The 3 dots here means we can continue writing 75 on the right side of this decimal. So this is an example of a rational number. Another example, negative 3.25. This is a decimal that stops. So it is a rational number. Last example, negative 6.6. Please notice here that there is a bar on top of the 6 on the decimal. We can write this into negative 6.666 and so on. So the bar there means we will continue write the 6 on the right side. Now, in our second example here, this example 2.1757575 can be written like this. 2.175 and there is a bar on the numbers 7 and 5. Example 1. Are the following statements true or false? Give reasons for your answers. Let's have statement 1. Every whole number is a natural number. This is false because 0 is a whole number but not a natural number. Second statement. Every integer is a rational number. This is true because every integer m can be expressed in the form m over 1, and so it is a rational number. Statement 3. Every rational number is an integer. This is false because 3 over 5, a counterexample, is not an integer. Example 2. Find 5 rational numbers between 1 and 2. Since we want 5 numbers, let us write 1 and 2 as rational numbers with denominator 5 plus 1. Therefore, it is 6. So, the number 1 can be written as 6 over 6. For number 2, this is 12 over 6. Then, the numerators 6 and 12, let us consider the numbers, the integers between the 6 and 12, and write as numerator for new fractions using the number 6 as denominator. That will be 7 over 6, 8 over 6, 9 over 6, 10 over 6, and 11 over 6. These are all rational numbers between 1 and 2. When we simplify the fractions, we have now 7 over 6, 4 over 3, 3 over 2, 5 over 3, and 11 over 6. These are the answers. Notice that in example 2, you were asked to find 5 rational numbers between 1 and 2. But you must have realized that in fact, there are infinitely many rational numbers between 1 and 2. In general, there are infinitely many rational numbers between any two given rational numbers.